Good morning, ladies and gentlemen. Welcome to Math 20-1, Chapter 6, Preview, Trig Ratios. Now, I have to talk a little bit about trig and trig ratios before we get into the meat of this chapter. First, we start with the history lesson. The trig ratios, we originally studied them for astronomy and religious reasons. Literally, we would look at the stars in the sky and see how they moved. Now, they would start, now in the northern hemisphere where we are, they would start in the east, or the first quadrant, and they would rotate to the sky as we watch them, and go into the second quadrant. Now, if you're far enough north, you would see the star rotate down into the third quadrant, and eventually into the fourth. Hence the quadrants 1, 2, 3, 4. All this based on ancient astronomy. Now, I also want you to remember, going back to Math 10, or 10C, and if I taught you Math 10C, we did this as a class, but the trouble with measuring stuff, in the old days, you made your own ruler. So your ruler would be different than your neighbor's ruler, than the person down the street. So these ancient astronomers, how did they communicate with each other? Well, everybody had a different ruler, everybody had different lengths, but what they realized, ratios were the same. So if we look at the adjacent side, sorry, measuring the angle from here, you have the adjacent. This is your opposite. This is your hypotenuse. You could calculate ratios, and then the units would cancel out. Now, here on a circle, I want you to note here, they did this entire length here. I'm having a brain fart. We would only talk about half of this chord. That's it. From top to bottom is a chord. This is half a chord. And a bad Latin translation of the Arabic or Hindi word for half a chord is sine. Here, the distance from the center to the edge here, or the to the chord, this line here, is called, oh, I apologize. My ancient Arabic sucks, but the Latin translation of the Arabic word for the adjacent sign here is cosine. So you have sine, which means half a chord, and cosine, which means the side beside. And then we have our hypotenuse here. Now, so far so good? And one other thing. Some of the guys realized very quickly, getting into decimals, if you made this hypotenuse 1, it made the math a lot easier. So when we talk about our angles, quite often we set our radius, our hypotenuse, equal to 1 when we're solving for the other sides. Now, here, there's 3 special angles I want you to know and remember. And yes, you can cheat and do this on your calculator, but if you look at this, draw the chord all the way through. What have we got here? We have a triangle. What kind of triangle is this? It's isosceles, where these two sides and these two angles are the same. Now, if you make this 45 degrees, like I said, hence special angles, this is 90. Okay? So far, so good. Now, what's special about a 90-degree or right-angle triangle? Mr. Pythagoras. We know this side, we know this side. A squared plus b squared equals c squared. So I'm taking a few minutes to show you where these numbers come from. You don't have to remember where they come from, but you do have to remember them. So the short side, the other short side, 1 plus 1 plus 1 is 2, which is c squared. So c is square root of 2. So this is the square root of 2. But remember, we're talking about this side of the triangle. So this is square root of 2 over 2 half. Okay? Root 2 over 2. Now, if we look at the adjacent side here, what have we got? Well, we have another right angle triangle. And I know the hypotenuse is 1. The opposite side is root 2 over 2. I can do the math and figure out what the other side is. A squared plus b squared equals c squared. So root 2 over 2 plus b squared equals 1 squared. Sorry. So this is 2 over 4 plus b squared equals 1. B squared equals 1 minus 2 over 4, which is a half. B is the square root of 1/2. Okay? Now, I'm okay with that, but some people get right uptight. Well, actually, it's from the good old days. They don't like having a square root in the denominator. Now that we have electronic calculators, this doesn't really matter, but how do you rationalize the denominator? Multiply top and bottom by square root of 2. So our adjacent side is also square root of 2 over 2. Right. Now, by the way, what is square root 2 over 2 on your calculator? Second square root of 2 divided by 2 is 0.70710678812. Okay. Remember that number for a moment. Sorry, wrong score. Now, as I said, you have to know where the number comes from. But I didn't say you had to remember the number because Mr. Calculator would tell you. Now, if this is our opposite side, this is our adjacent side, and this is our hypotenuse, where have we seen opposite, adjacent, and hypotenuse before? Well, you should pull out your formula sheet. Sine of theta is opposite over hypotenuse. In this case, root 2 over 2 divided by 1, or root 2 over 2. So sine of 45 degrees is root 2 over 2. So if you don't believe me, go to calculator. Sine 45. It's the same number, 0.707. Now you have to be able to turn that into the fraction root 2 over 2, so remember that. And what is cosine of 45? And I should close my brackets. The same as 0.707. Okay? I need you to remember this, root 2 over 2 for sine of 45 and cos of 45. And I want you to see where it came from. Now, 30 degrees, same idea. 1, 1. Now, 30 degrees. Now this is easier because if that's 30, that's 60 degrees in total, which means it's not isosceles, it's equilateral. This is 1. What is half of 1? 1/2. So, sine of 30 degrees is a half, the opposite side, or technically a half divided by 1. Now, what is my adjacent side here? Well, once again, setting up Mr. Pythagoras. 1/2 squared plus b squared equals 1 squared. 1/4 equals, plus b squared equals 1, b squared equals 4th, b squared equals 3/4. B is the square root of 3/4, which is square root of 3 over 2, or 0.866. You will see this number. Double checking. Square root of 3 divided by 2 is 0.866. Same as cos of 30 degrees, 0.866, which is the same as, excuse me. Sorry, I'll get to that in a moment. Now the other angle we did was sine of 30, should be a half, as we said earlier. So Mr. Calculator will spit out these numbers, but you have to be able to turn them into these fractions. Okay? So cos of 30 degrees is root 3 over 2. Oh, I haven't done tan. Tan of 30 is opposite over adjacent, which becomes 1 over square root 3. That I don't need you to remember, but sine and cos I do. I'll harp on them in Math 20, and I will harp on it and harp on it and harp on it in Math 30. Now, the last one, 60 degrees. 60 degrees, that's 1. Okay, then we're going, oh, wait a minute. Stop. Think. Right angle triangle. That's 30 degrees. What's the side opposite? Half. The side adjacent is root 3 over 2. So, sine of 60 degrees is root 3 over 2. Cos of 60 degrees is 1/2. Yes, I expect you to remember these numbers. All right? Now, shortcut for this, 0, 30, 45, 60, is the cosine is the square root of the number of fingers divided by 2, and the sine is the number of fingers divided by 2. The cosine is the number of fingers above the line, and the sine of theta is the number of fingers below the line. So let's look at sine of 30 degrees. So cos of 30 degrees, how many fingers are above it? 1, 2, 3 fingers. So that should be the square root of 3 over 2. Sine of 30 degrees, there is 1 finger below, square root of 1 over 2, which is 1/2. Okay? So let's do 45. See if you remember that. Cos of 45 degrees, there's 2 fingers above, so that's the square root of 2 over 2. Sine of 45 degrees, there's 2 fingers below that, square root of 2 over 2. Not 0.707 something something something. I'll be mad if you do that. All right? So this is the left-hand cheating shortcut for figuring out angles. Now, so far so goodish? Okay, what about 0 degrees? What is cos of 0? Well, we have 1, 2, 3, 4 fingers above. 4 over 2, which is 2 over 2, which is 1. And sine of 0 degrees, we have no fingers below, so the square root of 0 over 2 is 0. If you don't believe me, check your calculator. Cos of 0 is 1, and sine of 0 is 0. Okay, so this is a nice cheating shortcut to remember the important trig ratios. And eventually I'll talk about how some poor guy sat down and did these triangles for every angle between 0 and 360 degrees to 1/10 of a degree. Yes, that's 3,600 calculations. Anyway, what you guys have to know, tan of theta is opposite over adjacent. Now, I like writing it like this. Opposite equals adjacent times tan theta. I find it conceptually easier, whatever. Sine of theta is equals opposite over hypotenuse. I like writing it like that, opposite equals hypotenuse times sine of theta. And cos of theta is adjacent over hypotenuse. I like writing it like that because, and the ones that are circled, I'm going, oh, do I multiply or divide? Well, sorry, if you remember this, you remember the horror. Do you multiply or divide the numbers? So let's do a couple of questions here. So when I say solve the following triangles, that is find the missing angles. Now, here we do not know angle E, and I'll point out we don't know the side opposite angle E, which is side E. Oh, Poopy, you can't do this. Oh, my apologies, typo. Make this 30 degrees, not theta. Then the math becomes a lot easier. No. no, stop. Sorry. No, I gave you two sides so we can figure out the sides and the angles. So, solve the following triangles: angle E, angle G, and side E. So, off the bat, now I'll do this one with you, then we'll come back, I'll pause the recording, you do the next one. And I want to say there's more than one way to solve this. Okay, so I'm just going to solve for angle E first. Now, I have for angle E, this is the hypotenuse, and this is the adjacent. So if I go adjacent hypotenuse, cos of E is adjacent to hypotenuse, or hypotenuse times cos of E equals the adjacent side. Wait, getting ahead of myself. No, don't need to do it that way. The adjacent, sorry, is 7 over 12. So angle E, cos to minus 1 of 7 over 12. Yeah, sorry. Do it the easy way, Mr. Sutton. Oh, dear. Getting old, I apologize. So inverse cos, or cos to the minus 1, 7 divided by 12 is 54.3 degrees. Let's go to a decimal place, 54.3 degrees. Now, what's the easiest way to find angle G? Well, three angles in a triangle equal 180, so minus 90 degrees, that's angle F, minus 54.3, that's angle E, gives me angle G. Okay, plus 90 equals, give me minus 35.7, so this is 35.7 degrees. Now, last thing is how to find side E. Well, I can do Mr. Pythagorean's theorem. I can, let me see, I can do cosine, I can do sine, I can do tan. What's the easiest way to do this? Well, they're all easy. We might have a calculator. I'm going to go tan of theta is opposite over adjacent. That is opposite equals tan theta. Wait, adjacent tan theta is the way I wrote it out earlier. No. So, why am I writing it this way? Well, I know this angle. Well, I roughly know it. So the opposite side, E, is my adjacent 7 times tan of 54.3. Now, honestly, I shouldn't do it this way because there's a chance I screwed up 54.3 degrees. I really should be doing this Pythagorean because I know 7 and 12, but I just feel like doing this Triggy way. E is 9.74, 9.7. All right. Now, I'm going to pause the recording. I want you guys to solve the KMN triangle. Notice I've given you an angle and a side, the opposite side. When you come back, we'll compare answers, and yes, there's several ways to do this. I don't care. Do one of them, solve it, and figure it out. Remember, we need side M, side K, and angle M. Whatever is easiest for you guys. Okay, pause the recording, let's go. Okay, guys, so solving this, I got lazy, and I figured out the easiest thing to find, the easiest angle to find is, the easiest thing to find is angle M. 180 minus 35 minus 90 gave me 55. Now, keeping on going, I decided to do a tan of theta to get the adjacent side, or M. Now, notice how I rewrote this equation, opposite equals adjacent times tan of theta. I found this way to be a little easier because, can I remember, do you multiply or divide? If you write it out like this and solve for the unknown, I find to be conceptually easier. 8 equals M times tan 35. Divide both sides by tan of 35. I get 11.4. No. So that's 11.4. Now, the last side to solve for, or the last thing to know, is side K. Pythagorean's theorem works well, but once again, the 11.4, I might have screwed up. I do know my opposite side, my opposite side is 8, my angle is 35, and here I'm solving for my hypotenuse. So I chose to do it this way. Yeah, Pythagorean's theorem works too, as long as you don't screw anything up. And I got 13.9. Now, from my crude drawing, and you notice I do get picky about this. That's 8. Side n is 8. N is opposite. Side n is opposite angle n. That's 8. Then m is a little bigger, 11. K is almost twice as long. So yeah, it's a reasonable number. Now, if you get really desperate, you could always get a protractor and a ruler and draw it, and you'll get close. Which is why sometimes you'll see on the test, I'll give you an option of like 11.4 and 11.6. Not because I'm a poo head, because there's always somebody in the class who will try drawing it. Don't. Right? Now, so second favorite question, what is side x? Now here, I want to note, you got two different triangles. So you can do this. So if I go like this, oh yeah, I see the two triangles there. Now you should remember this from Math 10C. So how would you solve this? Well, this is the hypotenuse, which becomes, well, a side here. So here you would have to solve for the hypotenuse, given this is the opposite, sorry, try color coding, opposite to the angle 55. So what do we got here? Well, opposite hypotenuse, sine of theta, opposite over hypotenuse, opposite equals hypotenuse, sine theta. As I said, I like writing it out like that. 18 centimeters equals hypotenuse sine of 55. Hypotenuse is 18 centimeters divided by sine 55. $21.97. Now remember, do not do rounding off here, not until the end. I'm writing it at 21.97, but you'd leave it 9739426. The rounding off can creep in and give you a mistake, which is why sometimes you'll see the answer like 12.2 or 12.4, 12.6 on the multiple choice. So this is 21.97, 21.97. Now, how would I solve this? Let's Pythagorean's theorem. A squared plus b squared equals c squared. I should have asked for the angle, shouldn't I? Oh well, too late. So 21.97 squared plus x squared equals 26 squared. $482.85, blah, 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 blah. Square root of that is 13.9, 13.897, 13.9. From my crude drawing, yes, x looks to be about half the size of the hypotenuse. Exactly no, but close enough. I accept that. So that's honestly about as hard as it gets. Of course, variations would be what's the area of the triangle. I like this one because you have to find the height. Remember area? 1/2 base times height. So we need base, and we need the height. Okay. Now, how do we do that? Once again, we have two triangles here. So I have to find the base of this purple triangle, the opposite and the adjacent side. And the opposite side I use with this triangle to find the base side. All right? So let's get started. So height. Let's see, so that is the opposite side. And I got 9.389, 9.4. Now it's 9.38943 something something something. Do not round it off. I'm just writing out the rounding off part, or sorry, to save time. Now, adjacent side, cosine theta is adjacent, hypotenuse or adjacent, hypotenuse, cos theta. Adjacent is 20 cos 28. Which is 17.658, 17.66. So this is 17.66. Now, we also have to figure out this base here. Well, we have one more triangle, tan of theta, opposite over adjacent, or what is that? Oh, yes. Opposite equals adjacent tan theta. Our opposite side is our height. 9.4 equals 80 adjacent, tan 71. Adjacent. Now, scrolling up using the 9 point, where am I? 9.38 divided by tan 71. I would write that out. I'm just running out of space. 3.23. So 3.23 plus 17.69 gives us 20.89. So base is 20.89. The height is 9.39389.4. Use the exact values in your calculator. I'm getting annoyed with you. All right. Times gives me 98.08 or 98.1. So that's how you solve these. Now go give the preview. Do the check your understanding, and I'll see you in class.